Okay, this is just a quick video on how to do story problems that involve linear systems. Now let's remember that they are linear systems, so we need two equations. They each need to be linear equations, meaning there's some kind of x and y in them. They could either be standard form or slope-intercept form. Those variables might actually not be x's and y's. They might be something that pertains better to the problem. Variables that make more sense. But those variables do need to be the same thing in both equations. So if we're talking x's, each x needs to represent the same thing in both problems, or both of the equations. Let's look at some examples. Okay, let's suppose that we find $1.20 worth of coins in our couch cushions. And everything that we have found have been nickels and dimes. And so they add up to $1.20. They're all nickels and dimes, and there's actually a total of 15 coins. Okay, here is how we're going to make our equations. We know that they are all nickels and dimes. Nickels and dimes. And so we need two equations out of this information. One of them is what I call the count. That's the count of physical things. In this case, coins. So the number of nickels, I will use N to describe the number of nickels. D I will use to define the number of dimes, which that step right there of defining my variables so that I know what they are in both equations is kind of crucial and really helps clear things up. So those are the variables that I'll be using in this equation. And for the count equation, I know that that needs to equal 15. And what equals 15? Well, the number of nickels plus the number of dimes, so N plus D. The other equation is going to be the value equation. The total value of those is $1.20. And what is the value of a dime? Well, that's a 10-cent value times the number of them. And a nickel is a 5-cent value times the number of those. So we'll add that to the value of the dimes. So I've got the value of the nickels plus the value of the dimes is equal to $1.20. And probably an easier equation to work with than this one here is to just multiply all of that by 100, or in other words, don't work with it in dollars, work with it in cents. So instead of using that as equation, or the second equation, let's use 5N plus 10D, which nickels are 5 cents, dimes are 10 cents, instead of $0.10, $0.05, and that then is going to be equal to 120 cents. And so this equation right here is a little better or easier to work with because we don't have decimals floating around and whatever. That's also going to make it easy to use the elimination method when I use this equation as well. To finish this problem, we should probably have more space on our screen than this. So let me get to a new screen, but carry over these two equations. So here's the equations that I had from the previous screen. Let's use the elimination method and multiply equation 1 by -10. That will help me to eliminate the d's, and multiplying by 10 is easy. I don't need to get my calculator out to figure out what 5 times 15 is, for example, if I wanted to eliminate n. But proceeding here and multiplying, new equation 1 becomes -10n minus 10d is equal to -150. And so we subtract, eliminate the d terms. I've got -5n is equal to, what is that, -30. Divide by -5s, and I think we get 6 nickels. And then I go back to this original equation 1, plug the 6 in, plus d equals 15, subtract 6 from both sides, and I've got d equals, I think, 9. So I've got 9 dimes and 6 nickels. Let's look at another example. You should probably pause the video lesson right now so that you can read through this problem really quickly, because I'm just going to proceed as though you knew what is being said here. We've got 15 workers, and that tells us a total count. We've got $2,400. That tells us a total value being spent on them. So let's set up those two equations right now. I've got a total of 15 in count of workers. I've got a total of $2,400. And so what equals the 15? I need to define some variables. So let's call the number of workers. Oh, they define the variables for me. X is the number of the more expensive ones, and Y is the number of least expensive ones. So this is the guys at 180 per day, and Y is the Y is the number of guys at 155 per day. Okay, so there my variables are defined. So the number of the expensive ones plus the number of the less expensive workers is equal to 15. And the amount that I'm spending on them, well, that would be 180 times the number of them. So 180 times X plus 155 times Y is equal to this. Again, I can use linear substitute or the elimination method to figure this out. And I'll just eliminate y first, I guess. So I'm going to multiply the first equation by negative 155. And that's going to make negative 155x minus 155y equals negative 2,325. Do the subtraction here. This is gone. And we think we get 75 left over on the right side and 15 on the left. Whoops, that's 25. So then divide both sides by 25s, and we get x equals 3. So there are 3 of these expensive guys, which means there must be 12 of these. So y equals 12. And that's how you solve those. Particularly the setup, the work that I've done in red, I think is what most students have a problem with. By the time that we've hammered out just a few problems that aren't associated with story problems, they seem to get the elimination method just fine. It's the setup, and really the big tricks are: 1, define your variables and make sure that you're using the same thing in both equations, and then 2, typically one of the equations is just the count of physical things, like in this case it was the count of workers, or in the previous problem, how many coins are there, and how many of each type, and then usually the second thing has something to do with some kind of value of dollars or time or something else. So I hope that helps.